Okay, so for a volume of an object that is taken with a cross-section that runs perpendicular to the x-axis, the volume is going to be the integral from A to B, which they typically give us A, B, of my area dx. So A here is equal to our area. And that is typically the area of the base that is formed by the x and the y-axis. The other type of volume that we can have has a cross-section that runs perpendicular to the y-axis. It is very similar to this previous one, but instead of being in terms of x, it's in terms of y. So my volume is still equal to the integral, we're going to say from B to C, of my area in terms of y dy. You have to ensure that if we have it in terms of y, everything is in terms of y, including our integration bounds. It also so happens that those area formulas that we're going to use are typically known ones to us. So it'll be like the area of a triangle, the area of a square, semicircle, rectangle, stuff like that. They will be known geometric figures typically. So what we're going to do is we are going to calculate the volume of 6 different shapes, but they're all going to kind of come from the same parameters and the same bounds. This is the practice of changing between area formulas. And that's all we're doing today. So this one is going to be using the same area for each cross-section. The information that we're given about this area Okay, so the information we have about this base is that it has a triangular shaped base, and the region is bounded by these 2 equations and x equals 0. For each of these 6 different volumes that we're going to calculate, we're going to have a different cross-section shape. Okay, so this is the base information that we're going to use for all 6 of these, just the cross-section is going to change. So for part A, we are going to use a square cross-section. That runs perpendicular to the x-axis. Whenever we are given something like this, your first step is always to draw a picture. Okay, so what we're going to be drawing a picture of is the base because those are the parameters that we have. So I'm just going to graph the 2 functions that I was given. F of x is 1 minus x over 2. And then g of x is negative 1 plus x over 2. And then we're going from x equals 0 over. So it's going to be a triangle formed to the right here. It's the best I can. where g of x is the blue one and f of x is the red one. And again, we're really just going from x equals 0 over, so it's really just this portion up to the intersection. They intersect at 2 on the x-axis, and they each cross the y-axis at 1 and -1 respectively. If that helps you draw your shape at all. So what this particular problem told me is that I'm looking at a square cross-section that runs perpendicular to the x-axis. What that means is if I took a knife and I cut into the shape perpendicular to the x-axis, what I get out of it, or the slice I take out, is going to look like a square. So what I always like to do is I like to draw where the cross-section is coming out of. So this one is perpendicular to the x-axis, which means it cuts through it at a 90-degree angle. And the cross-section I'm getting out is a square. But you could pick anywhere.
Oh, just anywhere.
Yeah, any cross-section, so any slice I take out of that is going to be a square. That's what this told me. It doesn't look like it from the side, but we don't have a full view of the shape. All we have is like one view. So what we have to do is we have to find a way to relate these equations to the length of the sides of this square, because the only way that I can calculate the volume is to first find the area of my square, or the area equation. So I know that a square, of course, all has the same sides, right? All my sides are the same length. We're going to call them S. So how do I find S for any given point that I take a slice out of? Well, it's the distance between my f of x and my g of x, correct? Which means I can take my f of x and subtract g of x from it, because f is on top, to find the distance between them. So this side length is going to be equal to f of x minus g of x at every single x value from 0 to 2. It's not good enough to just say that it's equal to f of x minus g of x. I actually have to plug in those functions and simplify it out. So this is equal to 1 minus x over 2 minus -1 plus x over 2, because those are my f and my g. And then I simplify that subtraction problem. So this becomes 1 minus x over 2 plus 1 minus x over 2. The 1 and the 1 become 2. -1/2 and -1/2 become -1. So this simplifies into 2 minus x. So that means my side lengths at any given x value is equal to 2 minus x. This is what I'm going to use to establish my area equation, and then to establish my volume integral. Does that kind of make sense? Kind of ish. So we found the cross-section. We identified the shape of the cross-section. We figured out what we needed to establish the area for that cross-section, and then we'll use that to do our volume.
Didn't it just give us the shape?
It did, and it will pretty much always give you the shape. If not, it'll give you a really good picture of what it looks like.
All right.
Okay, so I found my side length. What is the area of a square? Length times width, or side times side, which here is going to be s squared. So my area is equal to 2 minus x squared, because it's side times side and my sides are all the same. Correct? We're okay with that? Which means my volume is my integral from x equals 0 to x equals 2, because I started at 0 and they intersected at 2, of that area equation. And you can plug that into your calculator.
Wait, why is it?
because it told me that my parameters was that it was bounded by f, g, and x equals 0, which means the y-axis.
And then 2 is where they intersect.
Right, so I had to go between those two. That's a really good question. So to find the volume, we just integrate the area equation. What'd you get?
8/3.
8/3 is correct. You should all get that at some point. If not, you should get what, 2.6 repeating. If you put the 2.6667, that would be okay as well.
So we only have to find the volume for these.
Yeah, it's only asking us to find the volume of each of these shapes based off the cross section that it gave us. Does that kind of make sense? Is anybody super confused by how we found the volume from this?
So each time do we have to draw to find out which one's on top and which one's on bottom?
No, because it's never gonna change.
So, f of
So you
x-
could use the same drawing for all of them. I'm probably gonna redraw them because I like to do that. And if you look at my notes, I redrew it for each one. But you technically don't have to, it's just your cross section is gonna change on them.
So will we always know that f of x is going to be on top though? Or
For every problem you're ever given, or just all of these?
for all these?
For all these, F will always be on top. Yes. Okay. Any major issues with that one?
So we said equal to area side.
We find the area of the cross-section shape that we were given and then integrate it. Is that kind of what you're asking? Let's do another example and see if that clarifies what your question was. Okay. So on this next example, which is going to be B, we're going to say that it's still a square cross-section. But this time it's going to be perpendicular to the y-axis. So I'm going to redraw the shape. I do suggest you do it for at least the first couple, and then you don't necessarily have to after that. Okay, so all I did was redraw the shape. We're still looking on the same bounds. That's not changing. What did change, though, between this and the previous problem? What changed? Perpendicular to what? The y-axis instead of the x. So before, I sliced this direction to get my cross-section. This time, I'm slicing this direction to get my cross-section. So we're just going to pick a random place, and we're going to pretend that we sliced a chunk out of it. And when I slice that chunk out of it, I'm still getting a square, right? That's still my cross-section shape. But the way I find the area of that square is going to be it's going to be a little bit different now. Okay, so that is still a square. My square still has side lengths of s.
Wait, why is it?
Why is it what?
Why is it up and down? Wider?
Why is what up and down?
Like the first square, you split it like this.
Right, because it said I'm running perpendicular to the y-axis now, and this is the y-axis. So perpendicular means intersecting at a 90-degree angle.
Okay, that's just.
So it changed where my cross-section was coming from. So the way that we're going to do this one, is that since I'm running perpendicular to the y-axis, I need to take both of my equations and change them so that y is solved for. Because that's the only way we can integrate using y as our basis for integration. So I'm gonna start with my f function. My f function was originally y equals 1 minus x over 2. I now need to solve for x so that y is in the middle of that equation. So the first thing I'm gonna do is multiply 2 into everything. I'm gonna subtract the 2 over. And then I'm gonna multiply everything by -1. So my new equation for that f is x equals -2y plus 2. That's gonna be important. I'm gonna do the same thing with my g function. I'm gonna solve for x. Using that same process. Are we all okay with that? So because we were running perpendicular to the y-axis, I had to transform all of my equations so that they were in terms of y and not x, because that's the bound that we're going to use now. Everybody okay with that? So now what I need to do is I need to figure out how I calculate the side length of my cross-section square, given that it now comes out of this part. So the actual question I'm asking is, how do I figure out this distance? Nope. Okay.
Triangle.
If I took this cross section, its height or its length is going to be from x equals 0 to x equals that, correct? Right? We see that? It's just that distance across, which means it's just the x value at any given y value. So from here to here, my side length is just going to be this f function, because it gives me the x value at any given y value on that interval. And then from here to here, it's going to be my g function.
So it's f plus g.
So I'm going to have two different integrals with two different y domains that I'm going to integrate and add the answers together. So again, all I did was I recognized that the height of the square is equal to the x distance from x equals 0 to wherever it intersects my f function, which is why it's my x for any given y on the f function.
So it's only equal to half.
It's only equal to this function for half of the interval that we were originally looking at.
So it's not a perfect square like the first one.
No, it's still a perfect square, but this function is only going to work for this top half, and g is only going to work for the bottom half, because it goes to where it intersects the function, and they intersect it too, so it means it splits somewhere in there. Does that kind of make sense? So that's how we figured out we're using two different ones.
So how did we set it up?
So the way we're going to set this up is first I need to figure out my area equations for each of those intervals. So going from -1 to 0, which is this bottom one, my area equation is going to be my g function squared from 0 to 1, which is the top half where it intersects my f function. My area is going to be my f function squared. And then that's how I set up my integral. Why am I using -1 to 1 instead of 0 to 2 as my integration bounds or my intervals?
Because it splits.
No. Why am I using -1 to 1 instead of 0 to 2?
Because why?
Because it's in terms of y. And 0 to 2 runs my x-axis, but -1 to 1 runs my y-axis. So that's what it means by everything has to be in terms of y to set this up. So then my volume for this first half is going to be the integral from -1 to 0 of the 2y plus 2 squared dy plus my integral from 0 to 1 of -2y plus 2 squared dy, and I can just plug it into my calculator again. So I use those given intervals with those given area equations to calculate my volume. What do we get?
I got an 8.
We should get 8/3 again. Yep. Which makes sense because I technically didn't change my three-dimensional shape at all. I just took a different cross-section. And then if we did units, you'd have to put your units on it.
Oh, why?
Okay, just
So
check it.
if it were a different shape, would
We
it?
would expect a different volume. Yeah. But technically, we didn't change our three-dimensional shape. We just took a different cut. I'm gonna wait till everybody has gotten 8/3. Do we get it, Erin? Rotary, you get it? Okay, it's all good. Okay, next one. So this time, instead of a square cross section, I'm going to have a semicircular. Looks like it's right. Yes.
Kind of a circle.
So it's half of a circle. And it's going to run perpendicular to the x-axis. So again, I still have that same drawing. My f function is still on top. My g function is still on the bottom. Except this time, my cross section is going to look like that. I know it goes up and down because it said perpendicular to the x-axis, which means it has to be a vertical cross section. So the real question is, how do I find the area of a semicircle? It's just half of the area of a normal circle, and the normal circle area is pi r squared, so a semicircle is half of that. Where this, oh gosh, is my radius. Right, radius is half the distance across the circle.
How do you find them?
Oh, I'm gonna show you. So the ultimate question is, how do I find that radius for my circle at any given x value? Remember, it comes from this. So it's just a semicircle taken from that cross section. So how do I find the distance or the length of that entire circle or height of the circle? How did we do it for the square? Top function minus bottom function gives me the area between them or the length between them. So that's the same thing, except my radius is going to be half of that distance because it's the halfway distance across a circle. So my radius is going to be 1/2 of my f function minus my g function, because I know that the f function is on top from the previous images that we've drawn. Does that make sense? So anytime we have two functions, one on top of the other, the distance between them is always going to be the top one minus the bottom one. We established that when we did areas yesterday. It's always the top minus the bottom for the, or a space between them. Does that kind of make sense? So now all I have to do is figure out what f of x minus g of x is. I'm going to split it in half, and then I'm going to integrate to find my volume. So my radius is equal to 1/2 of 1 minus x over 2 minus negative 1 plus x over 2. We simplify that out. We've already done all the work, so if you just want to pull it from before, that's okay too. So I just did f minus g, simplified it, and then divided my answer by 2. And I get that my radius is equal to 1 minus x over 2. Give you guys a second to finish that out. So then I take that radius, I put it in for r, and then I set up my integral for the volume. What's up? Well, we just take our area and we put a dx after it. So my area is equal to 1/2 pi of my radius, which is 1 minus x over 2 squared. So if I'm changing that into volume, it's going to be volume of the integral from, again, we're going from 0 to 2 because that's my x restraint of that function.
I was like,
Yep, we just literally take the area function and write it as an integral with bounds and a d, whatever our variable is after it.
I was having a break.
And then you can just put it in your calculator. It should be a decimal, but if you did as a fraction, it should come out to pi over 3. If you did the decimal, that's fine as well, as long as you take it to 4 decimal places.
So 1.0.
Yeah.
I don't think how I can do that.
It can, you can change it to fractions. Somewhere.
I tried, but it
Are we all getting either the fraction or the decimal on most calculators, or you can just go into your math functions and change it to a fraction from there?
Mine stays on fractions.
And it's a mode thing. It's just kind of the person. Decimals are 100% fine though. Did we get that to work out? Is that kind of making sense a little bit maybe? Okay, I know this is a hard thing to wrap your head around, which is why I'm spreading it out to 4 days. So we're doing this part today. We're going to do a particular cross section tomorrow. We'll do another one on Wednesday, not Wednesday, Thursday. And then Friday is just going to be a practice day.
Do we have homework over this? Or?
You will have homework starting tomorrow.
Okay.
Yes, but it's just going to be like 1, maybe 2 problems, probably just 1.
Okay.
Yeah, nothing crazy. Huh? No, we're going to do 1 more example. And it's going to be an example I kind of let you guys do, and then we'll fill in from there.
So part E.
Are we kind of all okay with this? Do we understand when we see it in front of us?
Yeah.
That's really what I'm going for. Maybe?
yeah.
Okay, some of you I see just staring blankly, and it scares me.
I'm freezing right now.
Sorry. I think it feels nice. So if you already wrote the notes, then this is actually example E. If you didn't, then you can call it D.
we gonna write example?
No, we're not gonna do E or F because I think they're just absolutely ridiculous and I don't see the necessity of them.
Okay.
But E is a really good one. So this one, its cross section is going to be an isosceles right triangle. Where the leg is bounded by the region and perpendicular to the x-axis. So we're still using those same functions. If you want to draw the picture, you don't necessarily have to. So the biggest thing here is I have to understand the placement of this isosceles triangle. So the first thing is, what do I know about an isosceles triangle? What is, not all the sides, but two of them, yes. So an isosceles triangle has two equal sides, and they're typically the legs. Well, they have to be the legs. And then the third side is your hypotenuse. So what this tells me is that the base or one of the legs of my isosceles triangle lies in the region, right? Which means it looks like this because it's running perpendicular to the x-axis, which means this length and this length are going to be the same. That's what this looks like when I take it out of there. Does that make sense how I pulled that information from what it gave me? So what I have to do is I have to figure out what those side lengths are so that I can create an equation for the area of a triangle. So if it looks like this coming from in here, where this is this cross section, how do I find the length of that side S? Where does it exist? Where does S exist on this problem?
F of G minus G. Or F of X minus G of X, right?
It's between F and G, right? Like it's fully between them, which means it's the top function minus the bottom function, which means it's F of X minus G of X for this side, and it will be the same as this side because it's isosceles. Yes, we did.
2 plus.
So both of these S's are going to be F of X minus G of X. We've already done all the work to figure out what F minus G is, and it's 2 minus X. Right, we've done this on at least 2 other problems already. So I'm going to pause. What's wrong?
Trying to figure out the area of the triangle.
Oh, how do we figure out the area of a triangle?
1/2 base times.
1/2 base times how? Base times height. What do I know about my base and my height on this particular triangle? They're the same because it's isosceles, which means it's really 1/2 times S squared here because my S is counting as both my base and my height because they're the same. So the area of this particular triangle is 1/2 times S, which is the same as 1/2 S squared. And I can just go ahead and put the S 2 minus X in for that. I said you guys were gonna do this one on your own and then I did it for you. And then from here, we just need to find the volume. So I'm gonna let you set up your integral using this area equation and then solve for what the volume would be of this particular 3-dimensional object with this cross section.
See, once we do it together, I think it.
That's usually how it goes. And when we do this, we get what? Answer rotary. What is it? 1.3 repeating, which is the same as the fraction 4/3. If you put 1.3 repeating, that's fine as long as you took 4 decimal places. No, you have to show 4 decimal places. I know, they're kind of picky. Okay, show of hands, got 4/3 or 1.3 repeating. Does this kind of make sense?
Yes.
Kind of. I'm looking for like halfway, half comprehension here.
Oh,
Because this is a lot. And I know it's a lot, and I absolutely loathe this, but we have to do it.
What we did yesterday.
I like looking at paper. I don't like thinking about going through paper in different directions.
Right. So what we're gonna do starting tomorrow is we're going to start with a shape that's created by some cross section, and it's gonna say find the volume of this when it's rotated around one of these axes. It's not much harder than this.
Shouldn't that be the same though?
It's not,
It's
huh?
the same shape though.
No, it's not, because this one would actually create a circle when it gets rotated around something. So this triangle would turn into a cone. It's gonna turn into something else. That's the kind of the point here. But it's not really setup-wise much more difficult than this, but this is why I kind of wanted to introduce it first. So you have no homework,
Yes.
and then tomorrow we will start with